Think about the last time you were working around a trench, maybe inspecting a large pipe or even just walking past a utility access point.
Hmm.
Did you ever wonder if there were specific rules governing entry into those enclosed or, potentially hazardous spaces?
It's a really important question.
In fact, some of these areas require a special permit before anyone can go inside. What exactly makes a confined space permit required? And, well, what are the potentially life-saving procedures involved?
Those are fundamental questions,
Yeah.
absolutely. And they really highlight why understanding the regulations around permit-required confined spaces is so critical in construction.
Right.
It's about recognizing that danger isn't always obvious, and that a proactive, systematic approach is just essential to ensuring everyone's safety.
Welcome to the Deep Dive, the show where we take your questions and your sources and dig deep to bring you the essential information.
Glad to be diving in.
Today, we're tackling a subject that's absolutely vital for anyone involved in construction: permit-required confined spaces.
Or PRCS, as you'll often hear it called.
Exactly. And you, our listener, have sent in some excellent questions, wanting to really grasp the intricacies of these regulations and understand how they translate into safer work practices.
Yeah, it sounds like people are looking to move beyond just knowing the rules. They want to understand the why behind them.
The why, yeah, why certain spaces demand permits, what those permits actually entail.
And the detailed procedures employers must follow to protect workers. It's about gaining that knowledge to spot hazards and understand the layers of protection that should be there.
So our mission today, using the OSHA regulations, specifically 29 CFR 1926 subpart AA as our guide, is to thoroughly explore this world of permit-required confined spaces.
We'll break down what triggers that permit-required label.
The step-by-step procedures for safe entry and also the crucial differences between these spaces and those that, well, don't need a permit.
And to help us navigate this pretty detailed but crucial area, we have our expert here, ready to shed light on these regulations, connect the dots, and ultimately help you understand what truly matters when working safely around confined spaces.
Okay, let's unpack this then. Starting with a foundational principle: preventing unauthorized entry. Section 1926.1204A is pretty clear. The employer must take measures to keep out anyone who isn't authorized.
That's the absolute first step.
What kind of physical measures are we talking about here? Like, what actually works?
Well, think of it as establishing a clear boundary, preventing accidental or, uninformed entry into a place that could be dangerous.
Like putting a lock on a dangerous cabinet.
Exactly. So
Yeah.
effective measures often include physical barriers, things like locked doors, maybe bolted or secured covers on openings,
Right.
or even just temporary barricades around the access point.
Yeah.
And signage is crucial.
It's just a sign.
Well, a very clear, visible sign, something that says unequivocally, permit required confined space, do not enter. It acts as a constant reminder. And in some riskier situations, you might even need a designated person just to control access. It's not just ticking a box. It's fundamentally reducing risk by stopping exposure before it can even happen.
That makes total sense. Create that first layer of defense. So, once we've got that covered, the next vital step, 1926.1204, is identifying and evaluating the hazards before anyone goes in.
Critically important, yes.
What kind of dangers could be lurking in these spaces? It's not always obvious, is it?
Not at all. The range of potential hazards can be pretty significant. Atmospheric hazards usually come to mind first.
Like bad air.
Essentially, yeah. Insufficient oxygen that can knock someone out fast.
Yeah.
Or, interestingly, too much oxygen.
How is that bad?
It dramatically increases the risk of fire. Then you have your toxic gases, hydrogen sulfide, carbon monoxide, maybe methane.
Stuff from materials stored inside or processes.
Exactly. Or flammable gases and vapors. Maybe welding happened earlier and flammable gases built up. The evaluation needs to cover all these possibilities.
Wow. Okay. So the air itself is a major potential threat.
Absolutely.
Yeah.
But the hazards go beyond the atmosphere. Physical hazards are a huge concern, too.
Like what?
Maybe unguarded moving machinery that hasn't been properly locked out and tagged out. Big risk of entanglement, crushing injuries.
Okay.
Then there's the danger of engulfment. Imagine working in a grain silo or even a trench
Oh, yeah.
where loose materials could just collapse and bury a worker in seconds.
Terrifying.
And falls from heights within the space, extreme temperatures, electrical hazards. They all need to be identified and evaluated. This assessment is really the bedrock of a safe entry plan.
Engulfment. Yeah, that's a vivid risk.
So a really thorough hazard ID and risk assessment is non-negotiable before entry, which leads us to 1926.1204, the requirements for actually developing and implementing safe entry procedures. This feels like the core of it all.
It really is.
Let's start with 1926.1204.1, specifying acceptable entry conditions. Yeah. What does acceptable actually mean here? Okay, so acceptable entry conditions are the specific requirements that have to be met and verified before anyone is allowed in. Top of the list is the atmosphere.
Right, the air quality.
Exactly. Oxygen must be in the safe zone. OSHA usually defines that as between 19.5% and 23.5%. Outside that, you risk asphyxiation, or, like we said, increased fire hazard.
Okay.
Then, any flammable gases or vapors have to be below 10% of their lower explosive limit, the LFL.
The LFL, that's the minimum amount needed to burn.
Precisely. So you need to be well below that point to prevent explosions. And finally, any toxic stuff contaminants must be below the permissible exposure limits, the PLs, set by OSHA.
So breathable air, no explosion risk, no poisoning risk.
That's the atmospheric part. Acceptable also means any physical hazards inside, like that machinery we mentioned, must be effectively isolated or controlled.
Yeah.
Think lockout out.
Got it. Now, 1926.1204C2 gives entrants or their reps the right to observe the monitoring or testing. Why is that step important? Seems straightforward, but
It's about transparency and trust, really. Allowing entrants or their representatives to actually see the testing gives them firsthand info about the conditions they might face.
builds confidence, I guess.
It does. Increases confidence in the safety measures, and it gives them a chance to raise concerns or ask questions about the results. It's another layer of verification, promoting that safety culture where workers are involved in their own protection.
Yeah, empowering people. Makes sense. The next point, 1926.1204C3, is about isolating the space and any physical hazards. What are some concrete ways to do that?
Isolation means physically separating the space from potential hazard sources that could creep in during entry. Several methods are used. Blanking or blounding, that's inserting a solid barrier, like a metal plate, into a pipeline to completely stop flow.
Okay, blocks it off.
Right. Or disconnecting equipment pumps, mixers from power sources, followed by lockout tagout to prevent accidental startup.
Standard LO.
Yep. Sometimes you see double block and bleed systems on pipelines, two valves closed, drain open between them, ensures total isolation. The goal is always a physical barrier preventing hazards from getting in while people are inside.
Sounds pretty robust. Then we get to 1926.1204C4, covering purging, inerting, flushing, or ventilating to handle atmospheric hazards. Ventilation seems like the go-to method often.
Ventilation is very common, yes.
Yeah.
It's often the primary way to control atmospheric hazards, diluting, removing contaminants, ensuring breathable air.
When is it required?
It becomes necessary if that pre-entry testing shows hazardous conditions, low oxygen, toxics, flammables. The goal is to get the atmosphere within those acceptable limits before anyone goes in.
And how do you ventilate? Just blow air in?
It depends. Could be forced air, pushing fresh air in, exhaust, pulling contaminated air out, or maybe a combination. It depends on the hazards, the space shape, all that.
Now, there's a specific note here about inerting. It sounds serious. It says if you can't get flammables below 10% LFL, you can inert the space. But then you absolutely need PPE for the atmosphere and must eliminate physical hazards.
Yes, inerting is complex and really a last resort because of the risks involved.
What does it do?
It means displacing the oxygen with a non-reactive gas, like nitrogen or argon, to stop combustion.
Ah, so no oxygen, no fire.
Correct. But you've just created an oxygen-deficient atmosphere, so anyone entering must use supplied air respirators or SCBA.
Right, trading one hazard for another.
Exactly. And the reg's emphasis on dealing with other atmospheric hazards and all physical hazards shows inerting isn't a magic bullet. It requires meticulous planning, special gear, highly trained people. It really drives home the point. Eliminate the hazard if possible. PPE is only for when you absolutely can't.
Okay. Moving to 1926.1204C5. Contingency planning if ventilation fails. It says monitoring systems must detect increasing hazards with enough warning time to evacuate. What kind of monitoring works for that?
This points to the need for continuous atmospheric monitoring while people are inside, especially if ventilation is the main control.
So constant air checks.
Yes, using reliable, calibrated multi-gas meters usually. They continuously sample the air and have alarms set for safe limits.
And the alarms need to give enough time.
Crucially, yes. Enough warning for everyone to get out safely before conditions become dangerous.
Yeah.
Might also mean backup communication systems too, just in case.
A safety net for the safety net. Makes sense. Section 1926.1204C is about protecting entrants from external hazards, barriers against vehicles, falling objects. Can you give some real-world examples?
Sure. Imagine a manhole opening in a work zone with trucks driving around.
Yeah, happens all the time.
You'd use concrete barriers, maybe traffic cones, high-vis tape to create a protected zone around it. Stops vehicles getting too close or driving over it.
Simple enough.
Or if work's happening above the confined space opening, risk of tools, materials falling in. So maybe install safety netting over the opening or just ensure everything up top is secured properly. Often simple, but incredibly effective.
Straightforward but vital. Next, 1926.1204 stresses continuous verification, making sure conditions stay safe throughout the entry. And it hammers home that point about PPE again. Only acceptable for hazardous atmospheres if the employer can prove it works.
Yes, it reinforces that fundamental safety principle. Engineering controls, work practice controls first, PPE last.
And continuous verification means.
It means acceptable conditions aren't just a pre-entry check. Things can change inside the work itself, ventilation hiccups, external factors. So regular, often continuous monitoring is needed.
And the bit about proving PPE effectiveness.
It's critical. Prevents just handing out respirators without ensuring they're the right type, fitted properly, and actually capable of protecting against the specific hazards at the concentrations present. Needs documentation fit tests, understanding PPE limits.
Got it. Last one in this section, 1926.1204C, eliminating conditions that make removing the entrance cover unsafe, like high internal pressure. Another detail that could be missed.
Absolutely. Think about trying to open a tank cover that's still pressurized.
Could blow off.
It could cause serious injury from the sudden release. So this mandates eliminating that condition first, depressurize, verify it's relieved before taking the cover off, anticipate hazards at every single stage.
Okay, that covers safe entry procedures. Now, 1926.1204D lists the equipment the employer must provide at no cost, maintain, and ensure is used correctly. Big responsibility.
Huge.
First is D1, testing and monitoring equipment. We've talked about this, but what's the employer's core responsibility here?
Providing the appropriate equipment for the specific hazards in that space. Calibrated, maintained gear for oxygen, flammables, specific toxics, and ensuring employees know how to use it right.
Then D2, ventilating equipment. Are there different kinds for different jobs?
Oh, yes. Forced air ventilation uses a blower to push fresh air in. Exhaust ventilation uses a fan to pull contaminated air out.
Or both.
Often, yes, a combination for continuous airflow. The choice depends on space size, shape, the contaminants you're dealing with.
Section D3 covers communications equipment. Between attendants and entrants, especially if one attendant watches multiple spaces. Mentions electronic communication, too. Why is reliable communication so vital?
It's the lifeline. Constant contact between inside and outside allows the attendant to monitor well-being, warn of changing conditions, coordinate rescue instantly if needed.
And for multiple spaces.
Even more critical then, two-way radios, maybe even video monitoring to ensure the attendant can keep track of each space and respond effectively.
Makes sense. Then D4 lists PPE, personal protective equipment, but we keep saying it's secondary.
Correct. The regulation emphasizes that.
Right.
While PPE like respirators, harnesses, gloves might be needed sometimes, the priority is always eliminating hazards via engineering controls, ventilation, isolation, or safe work practices.
And if PPE is needed?
Employer picks the right type for the risk, ensures proper fit, trains employees on use. It points to other standards too, like the respiratory protection one, covering medical evils, fit testing, maintenance.
Okay. Section D5 is about lighting. Needs to meet minimum levels, be safe for hazardous atmospheres if needed, and allow safe egress. So see what you're doing, don't cause a spark, and find your way out.
Exactly. Adequate light is basic for safe work and emergency exit. And if flammables could be present, all electrical gear, including lights, must be intrinsically safe or explosion-proof. Won't cause ignition. Plus, exit paths need to be lit and clear.
Sections D6 and 7 mention barriers and shields for external hazards, and safe ingress gear like ladders or hoists. Seems pretty fundamental.
They are. Barriers protect from vehicles, falling objects. Safe entry-exit gear, good ladders. Working hoist prevents falls, ensures controlled movement in and out.
Then D8, rescue and emergency equipment. Employer provides it unless an outside service will provide it reliably. So always be ready for an emergency.
Absolutely. Even with perfect planning, things can go wrong. So rescue gear needs to be on site. Retrieval systems like tripods, harnesses, lifelines, first aid.
And relying on outside rescue.
You need a documented plan. Proof the service is available quickly, trained for your specific space hazards, and properly equipped. You can't just assume the fire department is ready for anything.
Right. And finally, D9 is a catch-all. Any other equipment necessary for safe entry, exit, and rescue. Acknowledges unique situation.
Precisely. Gives flexibility. Ensures employers consider any specific tools or devices needed for a particular job beyond the standard list.
Okay, equipment covered. Moving to 1926.1204E, evaluating permit space conditions, the how and when of testing. It starts with E1, pre-entry testing. Generally, test before ventilation changes and before entry, but there's an exception for large systems like sewers.
Yes, for things like sewers where testing the whole system beforehand might be impossible.
So what do you do?
You test the specific areas where entry will occur as much as feasible. But, and this is key, if you authorize entry like that, you must perform continuous atmospheric monitoring right where the entrants are working.
Constant monitoring, then.
Yes. And the note mentions needing early warning for engulfment hazards in those flowing systems too. It's a risk-based approach, acknowledging practical limits, but demanding vigilance where people actually are.
Makes sense. Focus where the risk is. Section E2 talks more about continuous versus periodic monitoring. Prefers continuous unless it's infeasible or periodic is proven sufficient. If you do use periodic, how often?
The reg doesn't give a set time, like every 15 minutes. It says sufficient frequency to ensure conditions stay acceptable.
So judgment call.
A reasoned judgment, yes. Based on the hazards, the work being done, how quickly the atmosphere might change. The frequency has to be enough to catch a problem before it becomes dangerous between checks.
Okay. Section E3 gives a specific order for atmospheric testing. Oxygen first, then flammables, then toxics. Why that order?
It's based on safety and science. Oxygen first because weird oxygen levels too low or too high can mess up the readings of flammable gas detectors.
Ah, okay. Get oxygen right first.
Exactly. Ensure it's safe, 19.23.5%, then check flammables for fire explosion risk. Finally, test for specific toxics that pose health risks. It prioritizes the most immediate catastrophic hazards.
Makes sense. Sections E, 4, and 5 repeat the entrance rights, observe testing, and request reevaluation if concerned, still emphasizing worker involvement.
Absolutely. Empowers the workers entering the space. If they see something odd, if work changes, if they just have a bad feeling, they can ask for conditions to be rechecked right there with them. Fosters that proactive safety culture.
And ISERS wraps up this section. Immediate communication of test results to entrants. No delays.
Essential for informed decisions. Entrants need full awareness of conditions before and during entry to understand risks and take precautions. Transparency is fundamental.
Let's switch focus to the attendant. Sections 1926.1204 F and G cover this role. Requires at least one attendant outside for the entire duration of entry. What are their main jobs?
The attendant is the crucial link, the eyes and ears outside. Primary duties include continuously monitoring the entrance safety, maintaining effective communication, voice, radio, whatever works. They summon rescue if needed, keep unauthorized people out.
Can they do rescues themselves?
Only non-entry rescues, if it's safe for them to do so without entering. They are the dedicated safety observer for those inside. Their full duties are detailed more in 1926.1209.
But the reg also says an attendant can monitor multiple spaces sometimes, but only if they can still do their job effectively for each space. What determines if that's safe?
The key is, can they really monitor everyone effectively and respond immediately to an emergency in any space?
Depends on
How close the spaces are, how complex the work is, the reliability of communication, the hazards in each space, the emergency plan.
Sounds complicated.
It requires careful planning. The permit program needs clear procedures for how the attendant manages multiple spaces, especially handling an emergency in one without neglecting others. Entrant safety is always paramount.
Section H is about roles and training. Designate entrants, attendants, supervisors, testers, define their duties, provide thorough training, so everyone needs to know their job and be trained for it.
That's exactly right. Every person has a critical safety role. Clear duties for entrants, attendants, the entry supervisor who authorizes entry and checks precautions, the testers, and comprehensive training on hazards, procedures, equipment use, emergency response. Essential for everyone to understand risks and work safely.
Section I covers rescue and emergency services. Develop procedures for summoning help, rescuing entrants, providing services, and importantly, preventing unauthorized rescue attempts. That last bit seems key.
It really is. The instinct is to rush in and help, but an untrained rescuer in a confined space often becomes another victim.
So the plan must
Detail how to summon trained help 911, an in-house team, and strongly emphasize only trained, equipped personnel attempt rescues. Untrained people alert help and provide info from safety.
Got it. Section J is about the entry permit system itself, preparing, issuing, using, canceling it, and safely terminating entry planned or emergency. The permit is the central document, isn't it?
It absolutely is.
Yeah.
The formal written authorization. It has to contain key info, space ID, hazards found, acceptable conditions verified, required equipment, names of entrance attendants, supervisor's signature authorizing entry, emergency contacts.
And it has to be there.
Completed, signed by the supervisor, and available at the entry portal before anyone goes in. Then, when work's done or in an emergency, the supervisor formally cancels it. Entry is no longer authorized under that permit.
Section K addresses coordination with the controlling contractor when multiple employers are on site, crucial on big construction jobs.
Absolutely vital. The controlling contractor needs to ensure all employers involved know the hazards, the procedures, and how different jobs might interact and create new risks, inside or outside the space.
How do they do that?
Sharing permits, pre-entry briefings with everyone, clear communication channels, making sure everyone's aware and working together safely.
Section L is about concluding entry. Verify everyone's out, close the space, cancel the permit. Formal closure.
That's right. Securely close it up, replace covers, barricades, formally cancel the permit, prevents accidental re-entry under the old permit, signals work is done.
Finally, sections M and N cover reviewing and revising the permit space program. Section M lists triggers for review, like unauthorized entry, new hazards found, incident space changes, even employee complaints.
Yes, these triggers ensure the program gets reevaluated quickly if something suggests it's not working perfectly. Red flags demanding review and adjustment.
And Section N mandates an annual review of canceled permits.
Right. That gives a broader look back. Reviewing past entries helps identify trends, lessons learned, areas for improvement, even if no major incidents happened. It's proactive safety management, keeping the program relevant and effective.
So, as you can clearly see, navigating permit-required confined spaces, it's a really comprehensive, detailed process. It's not just about, checking a box.
Not at all. It's about a systematic approach.
Yeah.
Identify hazards, implement robust controls, ensure everyone's trained and protected, and be ready for anything, a total commitment to safety.
Absolutely. And for you, our listener, hopefully this deep dive gives a much clearer picture of what goes into a solid PRCS program.
Whether you're supervising entries, going into these spaces yourself, or just interested in construction safety best practices, these regulations are fundamental.
Knowing this stuff empowers you, right? Helps you see if things are being done correctly or spot red flags if they aren't.
Exactly.
Maybe one of the most striking things is that constant emphasis on hazard elimination or control before entry. PPE is always presented as the backup plan.
That hierarchy of controls is central.
Yeah. And the detailed rules for testing, monitoring the attendance role, emergency preparedness, it all just highlights the serious risks involved.
And it's important we also touch on the difference between permit-required confined spaces, PRCS, and non-permit required confined spaces, or NPRCS.
Right. Good point. What's the key difference?
Okay, so a non-permit required space still meets the definition of a confined space large enough to enter, limited entry-exit, not meant for continuous occupancy.
Well,
Critically, it does not contain, and have no potential to contain, any hazard capable of causing death or serious physical harm, especially atmospheric hazards.
so it's confined, but considered safe from major hazards.
Initially, yes. But, and this is crucial, if any serious hazard is identified later in a space thought to be non-permit, it immediately becomes permit required.
Until the hazard is gone and it's reevaluated.
Precisely. The classification isn't necessarily permanent. It depends on ongoing assessment.
We really hope this deep dive has been insightful for you. Are there other aspects of confined space safety you're wondering about? Maybe specific situations you've seen?
Yeah, questions that maybe still linger.
Let us know. Send us your questions, any sources you have. We're always ready for the next deep dive into the topics that matter to you.
And maybe leave you with this thought. In that whole carefully planned process of a permit-required confined space entry, every single procedure, every piece of gear, every trained person plays an absolutely vital role. What happens, what are the potential consequences when even one of those elements is missing, inadequate, or just overlooked? That's something to keep in mind every time you encounter one of these spaces.